43%. That's the number that stopped me cold. 43% of manufacturing tasks inside small and medium-sized businesses in the United States and Europe are still done entirely by hand. When you hear the word manufacturing, you probably picture a billion-dollar Tesla gigafactory. You imagine endless lines of pristine white robots moving in perfect synchronization, welding chassis and installing windshields in the dark. But that is not what American or European manufacturing actually looks like. The reality is that the vast majority of our supply chain is held together by small, unglamorous job shops. These are businesses operating out of industrial parks, generating $5 million to $20 million a year in revenue. They make the specialized screws for aerospace, the stamped metal brackets for commercial HVAC systems, the injection molded plastics for medical devices. And inside those factories, human beings are still standing in front of machines for 8 hours a day, performing the same physical motions over and over and over again. They taught you that the future of robotics was humanoid robots serving you coffee, or walking dogs, or doing backflips on YouTube. That is a lie, or at least it is a distraction. The real future of robotics, the part that is quietly printing money for a specific group of operators right now, is boring, stationary, and hidden behind the closed doors of small factories. My name is George, and after reviewing hundreds of business models, studying market data, and digging through the financial realities of modern industrial operations, I want to talk to you about the business of robotics as a service, or RaaS. Specifically, the business of buying industrial robot arms and leasing them out to small businesses. If you only act on one idea from this channel, make it the principle behind this one. It's the one that generates recurring income with the least effort once the system is built, and it solves a crisis that is keeping factory owners awake at night. Let's get into it. The first thing you have to understand is the crisis. If you talk to anyone who owns a CNC machine shop, a packaging facility, or a metal fabrication plant, they all have the exact same complaint. They cannot find people to do the work. The older generation of skilled machinists and assembly line workers is retiring, and the younger generation does not want to stand in front of a press brake for 40 hours a week. It's physically exhausting, repetitive, and frankly, boring work. So the factory owner has a problem. He has a $250,000 Haas CNC machine sitting on his floor. That machine only makes money when the spindle is turning. If there is no human operator standing there to load a blank piece of metal into the machine, press the green button, wait 3 minutes, take the finished part out and load the next blank. The machine sits idle. And an idle machine is a dying business. The obvious solution for the last 40 years was automation. Just buy a robot, right? But here's the part nobody mentions. For a small business, buying a traditional industrial robot is a financial nightmare. A bare metal robot arm from companies like Fanuc, Yaskawa, or ABB might cost $40,000. But that's just the arm. It doesn't know how to do anything. To make it work, the factory owner has to hire a robotics integration company. They have to build a safety cage around it so it doesn't accidentally kill a worker. They have to design a custom end effector, the mechanical hand that grabs the part. They have to write custom software. They have to integrate it with the CNC machine's computer. By the time that $40,000 arm is actually loading parts, the total bill is $150,000 to $200,000, and it requires a 100% payment upfront. It is a massive capital expenditure, or CapEx. For a small job shop that operates on 15% margins, writing a $200,000 check for a piece of equipment that might take 2 years to pay itself off is an impossible risk. If they lose the contract they bought the robot for, they are bankrupt. This is where the business model of robot arm leasing, or robotics as a service, steps into the gap. Let me be honest with you for a moment. What you're really buying when you build a RaaS business isn't the robot itself. It's the conversion of a massive, scary upfront cost into a safe, predictable monthly expense. Here is how the business actually works. Instead of the factory owner buying the robot, a RaaS company, the operator, buys it. But they don't buy the old school, dangerous industrial robots. They buy collaborative robots, or Cobots. Companies like Universal Robots dominate this space. A Cobot is designed to work safely alongside humans. If it bumps into a person, it automatically stops. It doesn't need a $20,000 safety cage. It is incredibly easy to program. The RaaS operator buys a Universal Robots UR10E, which costs roughly $35,000. They add a standard vacuum gripper or a 2-finger pneumatic gripper for another $4,000. They mount it on a mobile cart on wheels for $2,000. They add a simple 3D vision system for $5,000. Total hardware cost, roughly $46,000. But the RaaS operator doesn't sell this system to the factory. They lease it to them as an employee. Let's do the simple math. According to industry data and real operators on forums like R Manufacturing and R Small Business, the fully burdened cost of a human machine operator in the US is around $25 to $35 an hour. Note that I said fully burdened. That doesn't mean their hourly wage is $35. Their wage might be $18 an hour. But when you add payroll taxes, workers' compensation insurance, healthcare benefits, paid time off, the cost of HR, and the hidden cost of employee turnover, the real cost to the business is much, much higher. The RaaS operator walks into the factory and says, "I will put this robotic system on your floor tomorrow. I will program it. I will maintain it. If it breaks, I will fix it within 4 hours. You don't pay me a dime up front. You just pay me $15 an hour for every hour the robot works." To the factory owner, this is a no-brainer. They are instantly saving $10 to $20 an hour compared to human labor. But more importantly, the robot doesn't take smoke breaks. It doesn't call in sick on Mondays. It works the second shift and the third shift. It produces parts with exactly the same precision at 3:00 a.m. as it does at 9:00 a.m. And from a financial perspective, the factory owner shifts the cost from CapEx to OPEX, operating expenditure. It becomes a tax-deductible expense that matches their revenue. If they lose their manufacturing contract, they just return the robot. The risk is gone. Now, let's look at the math from the perspective of the RaaS operator, the person running the leasing business. You bought the hardware for $46,000. You lease it to the factory for $15 an hour. Let's assume the factory runs a standard 2-shift operation. That's 16 hours a day, 5 days a week. That is 80 hours a week, or roughly 320 hours a month. 320 hours times $50,000 an hour equals $4,800 a month in recurring revenue. At $4,800 a month, your $46,000 hardware investment pays for itself in less than 10 months. Let's say you factor in the cost of capital, insurance, and your own labor to set it up. Industry consensus puts the average payback period for a RaaS deployment at around 14 to 20 months. But industrial robots are built to last 35,000 to 50,000 operating hours. At 320 hours a month, that robot will run for almost 10 years. Once that 20-month payback period is crossed, that machine becomes a physical annuity. It is printing $4,800 a month, with profit margins hovering around 85%, because your only ongoing costs are occasional maintenance and software updates. If you scale this business to just 10 robots deployed across 3 different local factories, you're generating $48,000 a month in revenue, over $570,000 a year, with 10 machines. The boring factor is the advantage here. Nobody dreams about programming robotic arms to load metal blanks into a lathe. That's exactly why it pays. The business that's the most physically uncomfortable to do, or the most mentally unglamorous to think about, is usually the least competitive. Now, we enter the second half of this concept, where the reality gets more complex, but the profits get larger. Because here's the trick. YouTube gurus never explain when they talk about automation. You're not just buying a machine and dropping it off. You're selling a service, and you're taking on the liability of uptime. If that robot stops working at 2 p.m. on a Tuesday, the factory's production line stops. If the line stops, they lose money. Fast. In the RaaS model, the robot must be cheaper than the fully burdened cost of the human worker it replaces, but its reliability must be absolute. This requires the operator to master the value add. As an independent robotics integrator or RaaS provider, the hardware margins are actually incredibly thin. If you try to just resell a Fanyuk arm, you might make a 15% markup. The real profit is in the engineering, the custom programming, and the maintenance SLA, the service level agreement. When you read through the experiences of real integrators on Reddit, a common pattern emerges. Small to mid-size integrators often target profit margins of 50%, or they charge an implied $100 to $120 an hour for their labor and maintenance expertise. They achieve this by specializing in incredibly specific, high-value niches. Let's break down 3 specific applications where this leasing model is currently exploding. Application number 1, CNC machine tending. We already touched on this, but it is the bread and butter of the industry. A CNC machine cuts metal with extreme precision. The cycle time, the time it takes to cut one part, might be 4 minutes. A human operator standing there for an 8-hour shift spends 90% of their time just waiting. It is a massive waste of human potential. A leased Cobot mounted on a cart can be rolled up to the machine. Its vision system looks at a tray of uncut metal blanks, figures out where they are, picks one up, waits for the CNC door to open, places it inside, hits the start button, and then takes the finished part out and places it in a finished bin. The RaaS provider charges a flat $4,000 a month. The factory runs the machine lights out, meaning overnight, with the lights off and no humans in the building. That is pure profit for both the factory and the RaaS provider. Application number 2, palletizing. This is the end of the manufacturing line. Boxes of finished products come down a conveyor belt. Someone has to pick up a 40-pound box and stack it onto a wooden shipping pallet, perfectly arranging them so they don't tip over. It is backbreaking work. It causes immense physical strain and high workers' compensation claims. Enter the palletizing robot. This is usually a slightly larger Cobot, like the UR20, which has a longer reach and a heavier payload capacity. The RaaS provider installs the system at the end of the conveyor. It uses a vacuum gripper to pick up the boxes and stack them. Because palletizing is universally needed across food and beverage, consumer goods, and logistics, the RaaS operator can build one standardized software template and deploy it 50 times across 50 different clients. They aren't reinventing the wheel every time. They are copying and pasting a solution. And if this already made sense to you, wait until you hear about application number 3. Welding. According to data compiled from industry reports, the United States is facing a shortage of 400,000 welders by the end of the decade. Welding is an art. It requires high skill, steady hands, and it pays very well. But the work environment is harsh. Small fabrication shops literally have to turn away million-dollar contracts because they do not have enough welders to do the work. RaaS providers are now deploying collaborative welding systems. They use a standard Cobot, but the end effector is a welding torch. The genius of this system is that the factory doesn't fire their human welder. Instead, the human welder becomes the robot's manager. The human sets up the metal parts, manually guides the robot arm along the path to teach it the weld, and then presses go. The robot perfectly replicates the weld 500 times in a row. The human welder, who used to produce 20 parts a day, is now overseeing a robotic system that produces 150 parts a day. Because welding is a high-value, critical path operation, the RaaS provider can charge significantly more. Instead of $15 an hour, they might charge $25 or $30 an hour. The factory gladly pays it because it allows them to fulfill contracts they otherwise would have lost. The payback period on the hardware drops from 20 months to 12 months. Think about it like you're a kid. It's the difference between selling a single ice cream cone to a friend and renting the entire ice cream cart to the neighborhood for the summer. If you sell a machine, you earn once. If you rent the machine, guarantee its uptime, and solve the customer's labor crisis every single day, you earn every month. But I promise to tell you the uncomfortable truth, and here it is. Running this business is not entirely passive. It is not a software company. It is a physical operations company. When a proximity sensor fails because it got covered in cutting fluid, or when a pneumatic line leaks air, the robot stops. When the robot stops, the client stops paying. You have to have the infrastructure, the spare parts, the technicians, the remote monitoring software to fix it immediately. This brings up the concept of the U-shaped profit curve, a reality documented by researchers studying automation adoption. When a factory first brings in your robot, their profit margins actually dip. They have to change their workflow. They have to train their staff not to walk into the robot's path. There is friction. Your job as the RaaS provider is to hold their hand through the bottom of the U-curve until they reach the other side, where the technology drives scale efficiencies. This requires a massive shift in accounting and financial strategy. RaaS contracts often involve what accountants call embedded leases under ASC 842. The complexity of tracking depreciation, maintenance costs, and utilization rates is significant. You are essentially running a microfinancing company, fused with an engineering firm. Morgan Housel puts it in a way I never forget in his book, The Psychology of Money. He says that wealth is what you don't see. Wealth is the unspent income. Wealth is the hidden assets. The people making a killing in robotics as a service are not the ones on magazine covers. They are invisible. They drive F-150s, wear steel-toed boots, and spend their afternoons in loud, dusty industrial parks. They own a fleet of 25 robots distributed across 8 different factories, quietly generating $1.2 million a year in high-margin recurring revenue. Let's look at the two-person comparison. Consider Daniel. Daniel is a brilliant software engineer. He wants to build the next big AI startup. He raises $2 million in venture capital, hires a team in San Francisco, and spends 2 years building a complex machine learning model to predict consumer behavior. He is fighting against Amazon, Google, and 10,000 other startups for a tiny slice of attention. His customer acquisition cost is enormous. After 3 years, he runs out of money and shuts the company down. He chased the exciting idea and he stalled. Now consider Alex. Alex doesn't know how to code a neural network. But he understands that the machine shop down the street is turning away work because they can't find a second shift operator. Alex takes out an SBA loan, buys 2 universal robots, and learns how to program a basic palletizing sequence. It's not glamorous. It's boring. He places the robots in the shop on a 20-an-hour lease. Over the next 5 years, he reinvests the cash flow to buy a 3rd robot, then a 4th, then a 5th. Today, Alex doesn't have venture capital, but he owns a cash-flowing fleet of physical assets that run 24 hours a day. He built boring systems, and he succeeded. None of these businesses are brilliant. All of them are consistent. The money isn't hiding in the exciting ideas. It never was. It's hiding in the boring ones that nobody else wants to do. It's hiding in the friction. It's hiding in the unsexy realities of how the physical world actually operates. When I first started studying business, I was also looking for the genius idea. The app that would change the world, the platform that would scale to 1 billion users. But the uncomfortable truth is that the highest probability of wealth generation doesn't come from inventing the future. It comes from applying existing technology to deeply boring, universally painful problems in the present. Someone's labor crisis is literally your income. The question isn't whether industrial robot leasing is a good business. The math proves that it is. The question is, are you willing to do the unglamorous work of walking into a dusty machine shop, understanding their workflow, and taking on the liability of solving it? Ask yourself first whether it pays you once or pays you every month. Hit that like button. It helps a lot. Subscribe if you want us to keep talking about real money and business strategies that actually work in the physical world. Tell me in the comments if the concept of leasing robots to small factories makes sense to you, or if you still think it's too complicated to start. I'm George, and I'll see you in the next video.